This is an OLED display, very similar to the LCD display we've used on many projects before. The OLED display is just more accurate and it uses a bit of different technology. Personally, I think it looks 1,000 times better than the LCD display. Here's two pictures up on the screen of what the OLED screen will look like later in this video, and then LCD screen that we've used before. So on our OLED screen we have 128 times 64. And while on an LCD screen we also have pixels and we can control those pixels, we use this usually as a character display. There's 16 by 2 characters that you can type in here, so we've done like hello world, or we've used this as a timer or as a clock before, and that's usually the use case for this. With an OLED screen, you can go and control the pixels and do whatever you want. You can draw a picture on there, you can draw shapes, you can do animations, things that you can't really do that well on the LCD screen. Also, we should note that you can do really small font on here for letters and you can fit a bunch of text, and it's also like, what, a fourth of the size of the LCD display? So it allows you to display a bunch more information, animate it, fit it on a smaller platform, use less pins to activate it, less power to activate it, and it's about the same price as an LCD display. There are situations where you'd still use the LCD display and it's still very useful and all that, but I'm a real big fan of these because they look so cool. You can even go as far as getting a colored version of this. This one is just white and black and you can invert those colors, but you can go and get a colorful version of this and make, one pixel green, one pixel blue, one pixel yellow, purple, whatever color you'd like, and draw some things on the screen. The way it works is it's actually really simple. It has 4 pins on the top: ground, VCC, SCL, and SDA. Ground and VCC, as every sensor video I've made on this channel, ground is to ground, VCC is to power. In this case, you could do 3 volts or 5 volts. I'm going to be doing 5 volts. In your SCL and SDA, we've done these before on the LCD screen. SCL goes to 4, analog 4, and SDA goes to analog 5. So my board isn't actually soldered to the cables, so I'm just going to stick them through and let it loosely sit on them. Ground, VCC, SCL, SDA, ground, 5 volt, analog 4, analog 5. That's the pinout, that's the schematics, that's how you do it. Now once you got your board plugged into your Arduino through the cables and the pinout that I've showed you, go and open up your Arduino editor and let's go and start writing the code for this module. So here are the 3 libraries we're going to be including in our project. We can actually go and make this a little bit larger. We have the SPI library, the wire library, and the Adafruit SSD1306 library. That's because that's what the name of the sensor we're using is called. If you're getting an error when you're trying to upload the code saying these libraries are not included, not found, whatever it is, go into your tools and into manage libraries, search up SSD1306. So let's go do that quickly. And you should see one right over here by Adafruit for this specific module. The first thing you have to do is go and declare a couple different variables. First thing we're going to do is just copy this. X is going to be your horizontal pixels. So in this case, the sensor is 128 times 64. Depending on the type of board you're using, you need to declare the reset pin. So for this board, it's -1. If you're using a different board, just search up what number port the reset button is plugged into. But in this case, it's -1, so we're just going to do that. And now we can go and actually call this library. You can just copy paste that right here, and then you can type in display. And here we can put in the numbers we just declared. So we have X, Y. The third thing is you're going to have to be including your wire library, and before you put the wire library, just put this little symbol here. That's just pointing a reference to the library instead of actually copying it and putting in a new instance in there. And then go and call your reset. So now we're telling it the board is 128 times 64. You can give it the wire library, and then your reset pin, which is just R, is going to be the number which, when this gets activated, we're going to be resetting the screen. Now we can go and do whatever we want. So in setup, I'm just going to quickly set up my serial .begin. I'm going to have you guys type this little section out first, and then I'll explain exactly what it does, so just pause the video, take a second. What this section is doing is grabbing the address of your module, and then it's checking if it works, if it can find it, and if it's being able to display anything onto it. If you see this error, you might have the wrong address for your module, which is this little number here, 0x3c. If you are getting this error, I'm going to post a file in the description to a GitHub link. Just take that code, we can even do it right here. just paste it into your Arduino editor. So just upload it to your board, and then in your serial monitor, you should see a message telling you your address. IC2 scanner, device found at 0x3c. So that is your address, that's the one I already have, and it works perfectly for me. Then we can just undo all this mess and go back to our original file. Again, the code will be in the description for you guys, so you can just copy paste it, run it, check what it outputs, and then go back to your normal. The first thing you should do is call display.display. And every time you do this, every time you call the display method on the display variable, you're telling it to kind of print. Think of it as print. So you're giving a printer instructions, and then you're clicking the button print. You can tell it, all right, well, we want to print this picture of a dog, and then you press the button print. That's what display.display is doing. So we call it right away, and it's going to run like this Adafruit like display screen, this like default logo. Put a little delay so that it doesn't just run and then get deleted instantly. And then under that, we can go and clear the display. Now that we've ran that, think of that as your like initial startup. When you're starting up your computer, you see the Windows logo. This is like saying the Adafruit logo. And now under this, we can go and draw whatever we'd like. So I'm gonna go and just draw a pixel. So we're gonna go display dot draw pixel. And then here we can put the location of the pixel. So let's just put it at a random location on the screen. You also have to go, after you give it your X and Y coordinates, you have to go and tell it what color to put it in, because my screen only has one color, which is white, or you can invert the screen and it'll make it black. You can go and put in white in there, and then call your original display.display with a little delay. So let's go through that quickly. We're starting the screen and we're printing out the default logo for 2 seconds. Then it's gonna clear the display and it's gonna go and draw a pixel on this coordinates, a white pixel. It's going to print it out for 2 seconds, and then because we're not clearing the display after, it's just going to stay there. So let's go quickly and actually upload this to our board. Now on the camera here, I'm gonna have to zoom in really close to the sensor, just because the pixel gets really small. Seems like we forgot a little semicolon here, so let's just add that. Upload it one more time to the board. If you always want to know what your error is, it'll show down here. Again, another semicolon. The second it's done uploading, you should see your screen put that Adafruit display logo, and then we can see a little tiny baby pixel over there. It kind of looks like a speck of dust, some dirt on it. Let's go back into the Arduino program and grab this draw pixel and just copy paste it a couple times. Then I'm going to go into my X coordinates and just move each number by 1. We can go and do it 5 times. So now we have 5 pixels next to each other. Just going to go and upload that to the board, make sure everything is correct, there's no mistakes. Alright, we're good. And in a minute or so, we'll see that the Adafruit logo will pop up again. There we go. That's the first display.display, and then we can see that 1 pixel just became a little line. I made this little loop, and what it does is it starts at 0, 0 on the screen, and it draws vertically a bunch of dots. So it starts at 0, 0, it goes 0, 1, draws a dot, 0, 2, draws a dot, 0, 3, draws a dot, and then once it hits all the way down to 64, it moves over 1 and draws another line. So we can go and run this quick, and you can actually see it live updating on the little screen. This is the idea of how animating works on this screen. So you go, you make a change, you display.display. You make a change, you display.display, and then you can see it in real time on the screen. So you can't really tell something to move from one place to another and then display.display, because it'll just put the final product. You have to tell it at each point, at each keyframe pretty much, to go and print and update the screen. So if you're moving one dot from this block right here onto this block right here, you have to move it over, display.display. Move it over, display.display. Move it over, display.display. You can't move it all the way to the last one, tell it move from here to here, and then display.display, because it won't show that animation, it'll just print it in its final position. And now as you can see on the screen, it's drawing over and over a line, and then it's moving over to the next. Drawing a line, moving to the next. If I went in the bottom here and commented out this right here, and we uploaded that to the Arduino, give it a second, you'll see the screen uploads. So what happened here was it never showed the progress, it just waited till it finished all the dots, and then it said, all right, let's print it. Now the next thing we could do is go and erase this little example right here, and we can go and actually add some text onto here. Let's go on the bottom here and just make a little function. So we'll just go void hello world, and then inside of this, let's go grab display. I should put a dot here, clear display. Under that, let's go and use little text functions built into the display. So we have 3 of them. We have set text size. Let's go and put that at 1. We have display set text color. Like I said earlier, this is just a monocolor screen. So we just have white and put it in all capitals. And then we can go and set the cursor, so we're going to tell it to start right in. So then we can go and grab the cursor, which is just like your mouse, on the blocks on the pixels, and tell it to start on pixel 0, 0. So that's the top left corner. And then on that, just like when you print in your console, you just want to call print line, and then inside of that we can just go and put a formatted hello world, and then we can grab this function right here, call it right here. So what's going to happen is it's going to display the default logo, 2 seconds, clear the display, do our hello world, and then display it. And there we go, we see hello world, and it's quite crazy to see the text size difference between this board right here and using the LCD display. We can fit so much more information here, we can draw shapes and stuff, and I can even go in here and change the text size if I'm not happy with that one to a number like 2. The one problem is if you make the text size too big, which 2 is going to be too big, let's wait for it to update quickly, you can see that it doesn't actually fit on one line. You can also go and just tell it print line and split up those 2 words, and as you can see now we have hello and world on 2 separate lines. If you wanted more space in between, you'd have to either move the cursor and reprint the word, or add some kind of empty space in between, and it would separate the 2 more. But the fact that you can do whatever you want, move it wherever you want, you can put the world at the bottom left and hello at the top and have them move around, is just crazy comparing to what we started on this LCD display. So as I promised earlier, I told you I'd show you what a full animation would look like. I didn't write this. I'll leave a link below for the person who did write this on their blog page. But what they do is, the first thing is they have this line animation, then it goes into rectangle, then it goes rectangles that are getting filled, then it goes into circles, then it goes into circles that are getting filled, then it goes into round rectangles, then it goes filling round rectangles, then it goes into triangles, then it fills the triangles, then it just goes and draws a bunch of letters and draws some different styles, and then it does text animation, which is what we did earlier. This one is personally my favorite because this is what I'll actually be using it for. And then it does the Arduino logo. The Adafruit logo has it like fall from the sky. This one actually takes forever because the person had to go and physically draw bit by bit what the logo looks like. And then now that they have that, they can go and animate it on the screen. That must have taken a really, really long time. But that's pretty much it. We're able to go and turn on individual pixels, and doing that you can now go draw a shape, link it to a function, and then tell that function to go and draw a shape, or you can make it put text. You have infinite options of what you can do here. Personally, what I'm going to be using this for is I'm building currently a security system, and this will be the display to see who just put their key card into the security system, who just opened the door, You can check like the status of the security system. Is it armed? Is it disarmed? This will be giving you all that information instead of using like 3 or 4 of these that are huge and barely fit any information. The cool thing about these little screens is that they're so small and flush that you can probably grab 3 or 4 of them and then just line them up and then just tell it to put individual words on individual screens. If you enjoyed this video and you enjoyed seeing this little screen animate really cool things, please do give it a like and maybe consider subscribing to the channel. I have a bunch of cool videos coming out. So thanks for being here. Hope you enjoyed.